use the inverter for eliminating the harmonics. And the people say solar inverter injecting the harmonics into the grid. Then I realized, I think there is something wrong with these people. Either I am mad or these people are mad. Of course, so then I started working, of course, solar grid interface system. And what I observed that we have to certainly do the research, and probably my objective have been probably last 25 years, that in 5 years we have to be number one in the world, not to be second as far as research is concerned. Of course, we got a lot of funding. I mean, like typically maybe around total funding have gone be at 50 crore, but last probably 10 years we got funding around 25 crore or so to work on this system. What I observed that in India we need, of course, now my area typically, which talk about the power electronics originally, it really pirated probably the power sector or power system, you can call it, which my colleague used to say that, I mean, initially we started to start teaching HVDC and FAC, and later on he says you are putting all power electronics into power system, and later on after probably 5 to 6 years he also was convinced, Professor Bhim, that initially he says you are just putting power electronics, but later on he was convinced that entire power system is governed now by power electronics. The reason being that HVDC FACs, of course, for transmission system, but of course generation was not touched by power electronics. But you can understand the two technology, especially renewable energy generation, especially the wind and then followed by solar. I mean, we were very excited to put wind in India, and probably if I remember around probably 10 years before we put the wind around 40 gigawatt in India. But coming to 40 to 47 gigawatt, which was told in the morning lecture, it gone to 47 gigawatt. Now in the grid, it took around 7 gigawatt have come in last 10 years only. Because unfortunately, we don't have a good wind in entire country. We have only on coastal areas. I mean, and we cannot put the wind turbine in, you can call it into the water or sea, because our sea are volatile. But for Europe and North America, they are very lucky that their sea and lake are very, if really you travel from typically even Toronto to Niagara Falls, it's a 125 kilometer, but you will find a very big lake where you can have probably you can generate more than 50 gigawatt power from the wind, putting the turbine into the water. But we don't have that. We put only the coastal area. That was I feel that was one of the reasons why wind you couldn't go too big. But now, of course, wind are coming in the area where the low grade wind is there, like maybe typically in Rajasthan, which are not connected very close to the sea. But coming to then when we started to bring the solar, but solar will go big way. And that's exactly happened. I mean, we look at it in research also that how the technology going to be going ahead in next 10 to 15 years. Of course, we consider in the research around technology developed, what we do in the research is go to around 10 to, now it is coming closer 5 to 10 years or 10 to 15 years, but earlier I realized what we do the research is probably after 25 years it get converted into the actual field. But now the time is going to be really short. As the example is from solar. I do remember around probably 2012 or 13, the Haryana put probably the tender for solar. That time solar was 18 rupee, and it was apprehension that DG set generation was around 12 rupee. So it was apprehension that if you generate by DG set, I mean people will claim the solar. But you will not believe within a probably hardly in a probably 8 to 10 years, solar have gone probably from probably 18 to 6 rupee. And now in this decade, it's already gone from probably even a 6.5 rupee to 2 rupee. And I'm expecting that probably in the next 5 to 6 years, it will come 1 rupee per unit. I mean, normally our guests never go wrong. That's also another thing, that what we really feel, it will not go wrong. And whatever in the morning also told about the power sector, it's really going to be how we are going to add by 2030. Of course, federal government have decided to go 500 gigawatt solar, but it does not go like that, because we still in solar are only 90 gigawatt, which was the target by 2022 by federal government to go 100 gigawatt in probably in the solar. So, but of course the different schemes are there. I mean, of course we put the solar generation to put to the grid in different way. But there is a lot of now initiative are coming to use solar energy for, of course, converting it to electrical, but for different applications. Typical application, because everything is not supposed to put to the grid like that. So it's a major things comes like if I give you typical examples of putting like a rooftop, which are coming big way. And the federal government have decided, like even the Prime Minister have declared that 1 crore installation of 2 to 3 kilowatt have to come probably next 3 to 4 years, and government is supposed to give a lot of subsidy. And apart from there is a lot of push now for solar water pumping, which are not typically going to be connected to the finally feeding the power to the grid like also. So there are many applications like telecom towers also which are supposed to be put by the solar energy, and to be put not necessarily, maybe connected to the grid, but not necessarily the power supposed to be put to the grid so that it should be transmitted on the transmission line. Sometimes I differ with my power system friend when I talk about that probably whether we will require so much transmission later by putting this renewable energy, maybe wind for sure, but not necessary for the solar. And plenty of applications are coming day by day. Initially we didn't work into really those energy, but I was probably for few projects in around 8 years, even a couple of Indo-UK projects and SERI initiative by DST, Solar Energy Initiative. I suggested they give a lot of money for development of solar cell to R&D, lot of research, maybe especially. But I suggested you should give some money for the research for the developing the system. And that is the very much requirement of the country for developing the research for system, in the sense somebody can manufacture like the panel, but how to use the panel for probably final fill. And looking probably last few years, I am just experiencing even the development of panel. People say that it gives the 40% efficiency, but in actual field it's coming only 12 to 14% efficiency. I have a chance to look into a couple of projects from industry also. Why this is coming 12% or 15% when already solar modules or solar cell give around the 40% efficiency, where this probably 20 to 25% energy is going. And we are able to analyze in last 1 year or so, yes, where this energy is going. Because the problem is power system people never sit with the power electronics, and power electronics people never sit with the manufacturer of solar cell or solar module. So they are not sitting together, they become almost the enemy to each other. But the entire technology, when you develop, you have to come closer to each other, then only probably you can come. So we are able to look into the big, let's say, I will not say manufacturer, but the industry who are installing the solar now, and we discuss with them and we look into two things important. If you look into 3 4 years back, the solar probably was 33 or 30 rupees per watt. Probably last 2 years before it gone to around 22 rupees per watt, and today it's already, I was told, it's around 12 to 13 rupees per watt, and maybe probably next 2 years it's going to be 10 rupees per watt. So you can think about the prices are going to be day by day down for the solar, but you can understand the electricity. I feel really bad. The electricity is such a commodity. If you really going to buy some commodity in the market, like a fruits, if you want to buy 1 kg, the price may be very high. When you want to buy a 5 kg, the price may be half. But electricity is in opposite manner, that when you really want to take a small electricity, you are supposed not to pay even up to 200 units. I hope you understand what I say. 200 units you not to pay anything, but if you really consume, let's say, megawatt, you have to pay probably more than 11 rupees per kilowatt hour per unit like that. So this is a trend which we have to change probably, and we are responsible. Working people in the power sector are responsible why this is going to be opposite. And I hope maybe in a decade, we'll be able to probably change the scene. Much in the morning it was said that electricity is only, probably total energy, electricity is only 18% or 20%. It was said in the morning. But you know, the 50% energy goes to transport sector. And this is the time which India also decided that the transport sector, 50% energy also have to come now through electricity. So it's a great opportunity, or the great challenge will be there. Otherwise we will be really fighting in the manner, the way we are fighting with the CNG even after the 1 decade. You have a lot of line for the CNG, for the vehicle even the whole day. In spite it is more than 1 decade now, also. So maybe situation may be, for electricity may go more worse if really the transport system, which you talk about, whether it is a 2-wheeler, 3-wheeler, 4-wheeler, electric 2-wheeler, 3-wheeler, 4-wheeler or e-buses, and probably maybe even the big transport will come on the electricity, then situation may go more worse. So it is the time that really, country of course looking, now typically not only the probably administrator, but even a politician also realize that we need the electrical energy the great way. But I did involve a lot of research on this, but I was not involving too much to get implemented on it, either through a startup or something. The reason being that electricity is never appreciated by the community or the society. They consider it a free commodity. If you give the free, who will be giving responsible for the money? Research is apart. Even for implementation, if money is not given, I mean, who really will be responsible or putting the hand into it? Either the researcher or the implementation people. But time has come now, probably people have to pay. I mean, giving the example like electric vehicle, I was talking one day probably with some of the people. I mean, the electric car is to be charged from 25 rupees per unit, right? Because there are a lot of people sitting in the society, they want to take probably the quick money out of the things like, where we expect that the electricity to be for the charging system, if you put the solar, or you put the associated other energy, also maybe small hydro. I'm talking probably one week before, a person who want to develop probably electricity on the canal itself, putting a free turbine into the water, maybe a hydro, making a big hydro plant, it takes probably one generation around 25 years. But probably maybe putting a small turbine into the water of canal probably may not take even again more than a month or so, as we do in the solar. So I expect that this now, the electricity, especially the power, now it is getting revolutionized, that we'll be able to reduce the gestation period, and installation will not take probably more than maybe a month or 2 months, and we need very heavily probably the demand of electricity. And you can understand for India what is really our situation. If you go to North America, their per capita consumption is 25,000 units. And what is our consumption? I was told around now 1,500 units. Earlier it was 1,200 units, now it has come to 1,500 units only. So we have probably 20 times lesser than US, and people say that we have to go developed country by 2047. So it means you can think about hardly left how much, around 23 years. In 23 years we have to we have to really go to the electricity generation around how much? 20 times at least. 20 times what of today. And when you go to around 23, later maybe requirement may go even 4 times more. So probably there is a need that we have to increase the electricity generation around 100 times more or so to become a developed country. So it's a very scarcity need also. But people, of course, we expect that this have to come big way, and electricity generation certainly will come in very close, to this figure if you want to get developed country. And I can tell you, there is no other way getting a developed country. If you have electricity, or let's say electric power, then only you can become a developed country, otherwise there is no way. So I feel you have a very good, really many of you are related to electrical engineering, directly or indirectly related to electricity generation, because we need in electricity generation not only electrical people, we need the people typically from communication, computers, all these systems. Even their role is much more than what really we as electrical power people required into that. Because those systems have to be connected together, communicated together, of course, like a cyber attack and all things are there. So we need all the discipline in this electric sector also. So that's, my personal view, and of course we can have a discussion after. So I think I'm really within the time, not much before. Thank you very much.
Thank you, Professor Bhim Singh, for putting his thoughts on research in the area of renewable energy in the perspective of IIT Delhi research. Now I invite Professor Engineer Ashok K Rajput for putting his thoughts before the gathering. And to the audience, please prepare a few questions to be asked later when all 4 panelists have spoken.
Thank you very much, IEEE sections. Of course, the level is high of the IEEE, and I may or may not be up to the standard, but I will try my best with the blessings of my respective teachers and my respective seniors here, and of course my colleagues are here. And dear friends, good afternoon, Jai Bharat. I am thinking that I should start with a title known as the Progressive Development in Power Sector. What are the opportunities and how we are facing the challenges and coming over that. Bhim Singh Saab told that how the power quality can be managed, and I just came to know that he has written a book on power quality. Earlier the book used to be, I think, by Virgil. So naturally, after going from here, I will purchase the book to enhance my knowledge in this field.
Voice and
So actually the whole power system has developed in a gradual manner, and it was basically, you can say, the personally owned or owned by the small utility and locally serving some of the loads. The farm area was not being served in the beginning. Only some, those who could afford, they were being supplied electricity. And one more information which only very few may be knowing, Delhi was getting electricity from Meerut, around 42 kilometers away from here in the beginning. Later on, Delhi system developed. Now also the situation has not changed. Delhi is getting the electricity from far off places from the grid, and a strong grid is there. So that's the change from the pocket-based electrification to the large scale and total one grid in the country connected at different voltage levels. And right from, say, we here have 230 volt, 415 volt, that is, we are much familiar. The other voltages we have in the system, and those are the standards one. We cannot have the voltages other than those, otherwise it's uneconomical and the equipment itself will not be available. So just for information of the young ones, the 11, then in some places the 22 is also there, 33, then 66, of course in few states, 132, 220 kV, 400 kV and 765 kV. So this is in the AC. And in the DC also we have gone up to plus minus say 320 kV HVDC to plus minus 800 kV HVDC. Both LCC technology and VSC technology in the field of the HVDC are there. And you can say the comparison or the competition is going on that where we should put LCC and where we should put VSC, voltage source converter technology. Of course, both have their own plus and minus, but one of the famous company, I am not naming, they have stopped doing developments in the LCC and stopped manufacturing of the LCC. They are going only for the VSC. Reasons are technical and mostly the market demand and the competition. So thus you see that along with whatever future roadmap we develop, we have to remain constant on account of the availability of the material, the equipment, the devices, the process. Because cyber security is one of the things which tell us that you have to be careful at each and every step. And not only during the daytime or night time, but 24/7, you have to be alert. And that alert comes from the innovations, the firewalls, and whatsoever that we can do with the help of the automation and cybersecurity tools. So technology and innovations, they are very much required. And what I was talking right now, LCC and VSC and also the FAX devices, unfortunately we don't have the power chips manufacturing in this country. And you may be thrilled that some 4 companies are going into the manufacturing of the chips. But the disappointing part is that these are not the energy chips. These are the chips for other applications, mostly for EVs. There are companies here, because this is the highest academic forum and the academic platform here. I would like to say some of the companies, big companies of Indian origin and purely with the nationalistic mind, they are in touch with us. They need direction and the support from the government and other quarters. They want to develop their energy chips here. Not only silicon, but they will start from silicon carbide and later on gallium nitride, which are naturally far better than the silicon technology on which present IGBT and other thyristors are there. So that is the vision that we Indians have, and we have done many things. In order to transfer the power in high quantum and at high voltages, what we have developed the new things, the high temperature low sag conductors. And you would be happy to note that one US company and the Indian owner here has established that solid composite carbon core manufacturing factory in Pune, and that is the 5th one in the world. We motivated them, and it's just past 3 years development, and in the month of June they started the manufacturing also of that particular core. Similarly, many other developments are taking place. Supercritical boiler tubes, we motivated, and the companies have come up with the supercritical boiler tubes. But there are many challenges. The acceptance by the users is not so easy. They want the user certificate. So of course there are investment needs. Anything whatsoever we develop needs investment, but that need to be optimized. The government also plays its role that where the optimization could take place. Some utilities or say country, the discussion is going on whether we should develop the 1200 kV AC corridor also in some of the locations. So the parameters are yet to be fixed. Maybe say design have to be fixed, detail engineering has to be done, and as a policy we have to study whether we should go for such a high voltage or not at present. Of course in DC, HVDC, the maximum one plus minus 800 kV we have touched. In BSC waste also 525 or 500 kV is there. Earlier this was the limitation. So what challenges comes in our way is the right of way issue. Right of way issues not only in the form of the land, but because of the electrostatic and electromagnetic charges coming on the ground and coming in the vicinity. Those need to be studied, and various software tools and the advanced tools are required for studying the electromagnetic phenomena. Communication and protection systems, lot of developments are required. OPGW communication is a must now. Earlier it was microwave, and gone are those days. And the history says that microwave was used, and that band, frequency band of the microwave was required by the defense forces. So that was vacating, and OPGW era came. Superconductors are in the experimental stage, and just to feel you proud that under the CPRI research scheme by say CEA with the cooperation of CEA and MOP, the 315 kVA superconducting distribution transformer was developed. Now, when we are talking of the say ground-mounted solar and wind turbines, so when this will saturate, we will be looking for the offshore potentials, and the offshore wind power potential has been estimated as around 30 gigawatt. We would be making a modest beginning just to gain the experience, because where there the limitations are subsea cable, both HVAC and HVDC. We are planning to develop the subsea cables here. Reason being, whosoever are developing the subsea cables outside the country, particularly in the European world, their order books are full. Similarly, the order books for HVDC, STATCOM, and other devices, they are also filled. The biggest limitation with us is of getting the core material for the transformers. As you know, core is built up of cold rolled grain oriented steel, and that is not manufactured in India. And just to your surprise that only 13 to 15 mills throughout the world are holding those patents, you can say, or that technology. They are not ready to part with the technology. So that's the limitation. But now the government is paying attention, and for last 2.5 years we are listening that one company, JSW and JFE. JFE is of Japan, JSW is the Jindal Steel. They are in talk and surveying the market that how much will be the demand and how they can succeed in establishing the CRGO factory. So that thing has to come over. High voltage bushings, particularly 400 kV and 800 kV. The insulation paper and the insulation boards, they are also not available here. So these are some of the limitations. Make in India initiatives are being made. May I urge, may I request that you may give the list whatever you think that what should be manufactured in India, and on the equipment and material on which Indian standards are not there, or even IEC is also not there. Those standards can be developed in India. And wherever you feel, those who deal with the standards, they can intimate me that these standards are required for the country. Emergency restoration system used to be there, which Dr. Mukhopadhyay's time, the initiatives were taken, some plans were also made. Those so far were coming from outside the countries, mainly Canada and US. Now their dealers are here, but that is not a satisfactory condition. The ERS has been developed by the Indian companies and much better than those companies outside the world. Now come to the inverters part. We require what is known as the grid forming inverters. So that's a new field and these are the requirements. Energy chips I have told. You may tell when the time is. So far we have not tapped the geothermal potential, because geothermal potential lies in the country where there are difficult terrain. The normal grid, taking the conventional grid, is very, very difficult and sometimes impossible. So in those areas, say Lahore, Spiti and this J&K areas, the geothermal potential is there, and the country holds around 10 gigawatt of the geothermal potential. So many fire incidences also take place because electricity has all the advantages, but some of the things, because of our carelessness or because of certain defects or because of certain poor quality or damages, we have the incidences of the fire not only on homes and commercial buildings and markets, even in the bigger transformers. And for your information, CEA has developed, and it will come, say in few days on the website, the generic specification for a device known as nitrogen injection fire prevention system. So that we have framed at our own through wide consultation. Role of the distributed energy we should not forget, and I will finish with this sentence because many things are there, we can share at some other occasion. Say particularly all these transmission lines and that 500 gigawatt, and furthermore the 81 gigawatt of the thermal capacity which has been planned or which has been announced by the government, how this will be evacuated and how it will reach to the load centers. Because data center loads are the new thing. In my personal opinion, the data center should be located not in the metros, maybe at some other place, because already huge concentrated load is there from where the lines will come and from where the transformers will come to feed it. These could be located at some other strategic locations where the power is available and with ease it could be transported. That one thing at least we can do. We should not commit the mistake time and again. Another is the role of the DER. We should not. DER means distributed energy resources. The ponds or lakes in the villages can be developed, which have become dry because of the encroachment. They will revive. Water table will go up. Floating solar can come up there. And because India is a very diverse country, we are putting in lot of efforts, lot of emphasis, say biomass, burning with the coal. Not a good idea. But we are doing. We can use those local resources in the form of the DER, distributed energy resources, and support it with some other things. And maybe during the night time, the conventional grid, which still is existing, that may support. So that will reduce the burden on the high-end transmission system, and that high-end transmission system will supply the quality power to your data centers and other workloads. That's my model. And since more than 6 lakhs villages are there in India, if you consider 3 lakhs of the villages, and say on an average say 0.5 megawatt to 1.5 megawatt, if this type of the systems could be developed there, easily you will get a 300 gigawatt of RE, renewable energy, for which we are working hard, we are trying, and we are saying that integration challenges and all those things. So those challenges will be less, those could be managed well, and local supply will reduce lot of losses which are taking place in the distribution system. Thank you. Jai.
Thank you, Engineer Rajput, for presenting what industry is doing in CEA, Central Electricity Authority. And I hope that audience are noting some questions to be asked from eminent panelists. Next we have Engineer C Saxena from Grid India. He will present on power sector information.
Yeah. Good afternoon, everyone. And at the outset, I must thank the organizers for giving me this opportunity to be here amongst you and at this eminent conference, at this prestigious event, amongst the academia and my fellow industry experts here. So this is a great opportunity to be able to share my thoughts here. I represent the grid operator or the power system operator fraternity, and I must compliment the organizers to have selected the panel in a manner where we have the academia, eminent I have a very short presentation to cogently present my thoughts, Looking back to leap forward, the growth story, I think that the previous slide please. Yeah. So we are, in terms of the peak demand, this year May, we have already touched 250 gigawatt, which by itself is a big record that we have achieved. This was actually forecasted to happen sometime in August, but unprecedented and extended heat wave led to this demand being met in May itself. Thereafter, we have had much better rains and weather was been kind to us. So we have got much better this thing. But the CAGR is of the order of 5 to 6% in terms of peak growth. For the energy met, it's about, again, of the same order, about 5% or so. And in this, we have already crossed 5.5 billion units per day. So this is also a significant amount of growth, and 2030, 2032, 2037 and 42, this is supposed to grow more than double, in fact, from 1600 BU per year, we would grow somewhere around 3500 or so. So this is a very, very big leap that we are seeing. And not only is the growth happening, the load curve is changing, the load shape is changing, and we have new entities coming into the system like electric cooking. Electrification is a big way that is happening all around, and in India also we are seeing it. So electric cooking, electric vehicles, electrolyzers are coming in the future as well. Data centers was already mentioned, there are big concentrated chunks of load. Space cooling requirements are growing. As the society and as a community we progress, space cooling requirements are there, and of course the next driving imperative of course are the decarbonization goals. Next slide please. So in 2024, 250 gigawatt total installed capacity, around 445 gigawatts, non-fossil fuel based generation around 203 gigawatt, and wind and solar around 132. This does not include this year's addition, this financial year's addition. But then this changing resource mix is bringing a lot of challenges for all of us. Renewable integration in India is unique as compared to other countries because in India we have opted to go for large concentrated locations for renewable addition. We have large solar parks, we have concentrated wind parks, solar parks. So these are there implemented in the high RE zones, and they present in themselves unique challenges, unlike the rest of the world. Possibility of large disturbances has been is a real possibility. I think in the morning inaugural session, my CMD also mentioned about 8,000 gigawatt loss in about an hour or so, just because of cloud cover, and there have been incidences also otherwise. System strength so far by and large is not a very big issue, except in isolated RE pockets like Rajasthan, where we are beginning to see huge penetration of RE, but the load is away from Rajasthan, so power has to be brought outside. So those are areas where in future we would see system strength issues. Black start resources, if we have an outage in such high concentration RE pockets, then black start resources is what we need. And in this context, what my previous speaker mentioned about the grid forming inverters, they have a very important role to play. We need to go further and develop those also further. Power quality issues are being seen with IBR inverter based resources in picture. There are power quality issues and compliance to standard issues. So those things are also going to become a challenge. Earlier, transmission used to come first because conventional generation had a longer gestation period. This trend has reversed now, and RE has a shorter gestation period, and transmission takes a slightly longer time. So this mismatch again has to be handled. There are ways that are being handled. Changing resource mix also requires concentrated efforts in terms of managing resource adequacy in all time horizons. It's challenging because of penetration of behind the meter resources. As distributed RE penetration increases, distribution companies would have to have visibility of the rooftop and all those other behind the meter resources to be able to accurately forecast their resources. Next slide, please. So coming to the flexibility challenges that I mentioned, this is a recent plot from 4th of August. If you see on the left hand side, we have high frequency during the high solar hours. If you see here, the dotted line is showing the frequency. High frequency operation is happening, and we are trying to reduce generation. The red bars at the bottom are reducing the thermal generation to be able to absorb more RE, and we do not have down reserves available to reduce any further to be able to absorb more RE. So we are with increasing penetration, we are hitting a place where the entire interstate system of thermal generation has been brought down below technical minimum levels, and yet we need to go down further to be able to absorb more RE, which needs to be done. So flexibility is an attribute that is being demonstrated here, that minimum turn down levels of the thermal stations, faster ramping requirements, because these are thermal stations cannot be taken off bar. Evening, non-solar hours, we need these stations to meet the demand. So they need to ramp up quickly as the solar goes down very fast. Next slide, please. Resource adequacy. These are two typical day plots we are just showing. The first on the left hand side is low demand and high RE, and in this case, if you see, yellow is the solar at the bottom, and blue is hydro, and green is wind. You can see a thick line of green wind at the bottom of the chart, and the green line that you see here is the net demand. Net demand means minus RE, total demand minus RE. So you can see during the daytime it is slightly coming down. On contrast, if you see the high demand and low RE day on the right hand side, wind is hardly present and only solar is there, and you can see the net load is almost flat throughout the day. Now with these uncertainties and with this kind of variability in RE, your resource adequacy becomes very, very important. So you must plan for resource adequacy. In fact, on this high RE penetration day, the instantaneous penetration was 31% as recorded on 26th of May 2023. 31% of the country's demand was being met through RE. So this is a huge number, and if this disappears, then other resources must be called in. Next slide, please. So a lot of initiatives have been taken for reliable integration of renewables, and there is a comprehensive set of regulations by the planning agency, that is CEA that we have, and the Central Electricity Regulatory Commission, the central regulator, where a bouquet of regulations and standards have been provided for interconnections, operations of renewable plants, as well as the grid as well. Robust compliance verification mechanism has been put in place. Enforcement is being done of compliance to standards, and technical data, report submission, everything is in, models are being asked, simulation studies are being carried out, independent compliance verification by the system operator as well as the CTU is being carried out. Synchrophasers are being installed to be able to get deeply into the systems and analyze post facto also. Perspective transmission planning on rolling basis. I said that transmission now takes more time than, has a longer gestation period as compared to RE. So perspective transmission planning is being done in advance for RE pockets. RE zones are being identified and advanced planning is being carried out. Innovative solutions, I think this Mr. Rajput also mentioned, VSC based HVDC. Storage is going to play a big role in the future. Fax devices, synchronous condensers, these are being integrated into the system. A regulatory framework for short-term and long-term adequacy has been brought in place both by the CEA and the Indian Electricity Grid Code. Thermal flexibility initiatives are being brought out. Pilots projects are being carried out for technical minimum, higher ramp rates, and all those activities are being done both at the interstate and the state level. Dedicated renewable energy management centers co-located with the load dispatch centers are being established, and around 11 are already operational. Next slide. Yeah, this we were speaking about lot of transmission addition, and in this case additional requirement for interstate transmission by 2030 of 66 gigawatt has been already identified and is under implementation. 37 gigawatt of offshore wind auction trajectory has been announced by the government for till 2030, and evacuation systems have been planned for about 10 gigawatt. These offshore systems are identified largely in off the coast of Tamil Nadu and Gujarat. Green hydrogen mission is going to bring in additional demand to the system by 2030, and cross-border connections are going to be enhanced for the neighboring countries. Larger footprint would help absorb more RE. Next slide, please. Yeah. So the imperatives that are driving the change for exploring innovative business models and institutional strengthening are largely sustainability goals, electrification, extreme weather conditions, variable intermittent resources, and the Gen Z. Our Gen Zs, the younger people are more vibrant, they are more sensitive to the environmental challenges, and they are the ones who are actually driving the whole thing. So a lot of strategies have been adopted: structural, financial and regulatory reforms, enforcement of contracts, financial viability of the projects must be ensured, cross-border interconnections, larger footprint helps absorb more RE and harness diversity, financial contracts, peer-to-peer trading, smart grids, all those are being implemented. So digitization, flexibility, adaptiveness, resilience, these are the keywords that are being focused upon, and work is on in all these directions. And stakeholder outreach, I think this was also mentioned in the inaugural session. Stakeholder outreach and collaboration is a key to implementing this change that we are doing. Next slide, please. In the electricity market, we already have a very vibrant market for nearly now like 20 years or so. And we have developed over a period of time, matured, and we have a variety of products in different time horizons. Yet there are many blocks which need to be put in together here. Those are shown in the dotted. I would just mention considering the time limitation, I would focus on the dotted blocks which are required: resource adequacy demonstration and assessment and demonstration. Capacity markets are required. Shorter duration contracts are required now. Planning for reserves, financial instruments for hedging risks. Carbon pricing is another area where work is going on. Carbon market is being developed. Ancillary services, flexibility attributes need to be harnessed. Negative pricing may come soon, because in power exchanges we have seen prices going down during high solar hours, right up to 10 paisa per unit. Power is available at 10 paisa per unit in the interstate market. So we are at a stage, maybe we should start thinking about negative pricing as well. Next slide, please. Yeah, so this is a roadmap. I think this would not be much visible, but I think largely covered. Those future aspects are there, like carbon markets, flexibility attributes, capacity markets that I mentioned in the. So I would just skip this slide. So the way forward, is strengthening of regulations and standards and governing grid operations. Those are very, very important. Compliance to standards must be ensured. Identifying and reviewing the resource mix through resource adequacy and flexibility requirements must be met. Flexibility initiative must be given a thrust. participation of renewables in essential reliability services, frequency control and all must be provided, because these are very important areas. Going forward, when renewable is going to dominate the grid, we need these services from the grid, from the renewable itself. Moving to shorter duration of scheduling, metering, accounting and settlement, faster markets, and development of new market products, capacity markets, white certificates, carbon trading, and so on and so forth. Thank you very much. That is all from my side.
Thank you, Engineer Saxena. So much elaborative PPT you made, and I hope audience have immensely benefited out of this information. So next in line is implementation on renewable energy. Engineer Sanjay Sharma from Director SECI. He will be informing about what is government doing under renewable energy.
Thank you, organizers, session chair Professor Bhim Singh, Professor Mukhopadhyay and Professor Prerna Gaur, and esteemed guests sitting in front of me. So thanks for inviting me on this valued session, and I will break my session, whatever time allotted to me is 12 minutes or so, in two parts. One, specifically focusing on the topic, and second, what we are doing. Okay, so few faces I am seeing that those are dull. So young generation sitting behind, if you understand what I am saying in Hindi, please clap so that others will awake. यूं जमी पे बैठ के क्यों आसमान देखता है, यूं जमी पे बैठ के क्यों आसमान देखता है, परों को खोल जमाना उड़ान देखता है। और लहरों की तो फितरत है यूं ही शोर मचाने की, लहरों की तो फितरत है यूं ही शोर मचाने की, मंजिल उसी की होती है जो नजरों में तूफान देखता है। थैंक यू। So the topic given is progressive development in the power sector, opportunities and challenges. The power sector today is undergoing significant transformation driven by the technological advancement, policy shift and urgent need to save our climate. This evolution presents numerous opportunities and challenges that stakeholders have to navigate to ensure sustainable and resilient energy future. So first I will discuss the opportunities, because a lot of has been said by Dr. Professor Bhim Singh as well as Mr. Samir that we are in the RE phase. So we are adding most of the energy or say generating station in RE sector, may it be solar or wind or some other. So the opportunities are renewable energy integration, which brings technological advancement, and once we are adding the renewable energy, then that will increase the betterment of the infrastructure. This will invite more job opportunities, that will change the grassroots level, maybe the poor area or say backward area, into a very vibrant and means job creating kind of a business center. What we have seen in Bhadla, I have personally visited when our solar parks were being developed. There was nothing, all over sand dunes were there, and right now after 3-4 years of the development of the solar park, when I visited, the ecosystem has developed, hotels were there, everybody was getting job and everybody was happy. So another policy support, what Mr. Rajput sir has said, that the policy is the key, because implementing the government agency, the support of policy has to be there. So they devise the systems, procedures or say technical parameters. Based on that, we create the real thing on the ground. So that has to be there. Another opportunity, decarbonization goal. We all are living in this climate change area. We are also witnessing extreme weather conditions. we are also facing the problems of food security because of these weather pattern change. So all these have to be tackled, and that is done. That is the key, that RE should be in place instead of the fossil fuel. Another is grid modernization. Mr. Samir has faced a lot of problems in managing the grids. So smart grid is the solution. Smart grid is nothing but real-time monitoring and taking out the worst part, or say problematic part from the grid, and if that is not possible, if something has gone down, so we should bring the grid into the shape in a very minimal time. That is the smart grid. Am I correct? So another is electric transportation, EV. People have touched upon, but one thing I would like to mention, that in EV, if you are charging EV in Delhi, so from where you are getting this power? This is the significant point I just want to make, because it is the power you are getting from burning the fossil fuel or say coal. So Delhi pollution can be transported or transferred to the generating station point. Okay. Until unless those EVs are charged through RE, we are not going to solve any problem. The challenges, again, we are facing the grid stability and reliability. A lot of things have been said. I will not repeat. Aging infrastructure of the transmission system, that is also a challenge. Apart from that, we have to make the evacuation system emanating from the RE sector to the load center. So that is a big problem. Right now we are facing the biggest problem because the evacuation system is not ready. And even if we plan today, so that will come after 3-4 years. And our RE capacities takes only 1.5 to 2 years to be installed. So there is a lag of 2 years. So we have to plan ahead of 2 years whatever we want to install in RE. Investment and financing, that is a challenge, but I should not say it is a challenge, because right now because of the government of India's efforts, that our economy is facing each and every challenge but overcoming very fast. So the investors are having confidence in Indian economy. So investment is flocking from the globe. I am witnessing, yesterday also a few investors came to my office and they are ready to invest 2 lakh crores in Indian RE market. So that is the brand we have created in India, that investors are ready to invest in India in RE sector. So investment is not a problem. Regulatory and policy framework, which is a challenge, because day to day we are facing new problems. What we have witnessed in demonetization case, every 3-4 days some regulation was changed, because that was a sudden decision. So we are moving ahead very, very fast, and once we face the problem, then there comes a problem of that is to be supported by the regulation. What we have witnessed in industrial point of view, what I can say, that in wind energy, if the temperature goes above 40 degrees, so suddenly the wind turbines goes down, their generation goes down very fast. So that is again a big drop, and grid manager has to manage it in a very efficient way, and they are facing problem in again bringing back to the grid to stability. In a conclusion for this session, for this topic, the progressive development of the power sector offers immense opportunities to create a sustainable and resilient energy system. However, it also presents significant challenges that requires coordinated efforts from the government, industry, academia, and stakeholders. By addressing these challenges and leveraging the opportunity, the power system can play a pivotal role in achieving global climate goals and ensuring energy security for future generations. So now I would like to tell something about our company, SECI. It was formed in 2011. We started becoming this commercial company in 2015. and at that particular time the solar installation in 2014-15 March, it was less than 3000 megawatt. Right now, after 10 years, we have 90 gigawatt of solar only. So that means to say in 10 years there is 30 times increase in installation of solar. How this has come? Earlier the tariff was very high. Yes, Honorable PM started in Gujarat, the initial tariff was 18 rupees, and in SECI's tender it came down to 2 rupees also. So the generation of this solar started and this journey, and now not only solar, we are innovating in each and every product in electricity generating markets. So after solar, we bring out the tenders for hybrid projects which are under installation, means solar plus wind. Apart from that, we came out with the tenders of RTC, round the clock through renewable only. So that is also under implementation. Apart from that, we came out with the tenders of FDRE, that is firm and dispatchable power, which means to say we are making matchmaking kind of a thing of the load of the discoms with the renewable only. So that means to say every hour we have to match the load of the discom, whatever he has projected to us. So every hour we are matching through RE only. So that is the biggest, globally the first kind of a thing. We are just replacing the thermal power through RE. And the tariff we have discovered, we have done one tender for Delhi, BRPL and BIPL. This is 630 megawatt only, but the tariff discovered is less than 5 rupees. It is 4.98. The best part is that 4.98 is fixed for 25 years. Fixed for 25 years, there is no escalation. And if we see, if we want to install a thermal project today, so the capex cost is approximately 8 crore per megawatt, and that turns to the fixed cost and operating cost approximately 7 rupees. So today only we are cheaper than the fossil fuel. At the same time, we are also mitigating the intermittency and as per the requirement of the DISCOM. So this is what we are doing. So SECI has done in such kind of a thing RE tenders of 70 gigawatt, out of which 55 gigawatt the off-takers have been tied up, and 23 gigawatt we have already commissioned and under operation. This is what SECI has done. And now we have been given the implementation of the green hydrogen mission, wherein I can see the slide that our mission says that a 500 million metric ton green hydrogen to be produced by 2030, which again requires the RE power of 125 gigawatt. So that is in addition to 500 we can oversee, but the challenge is only the evacuation system, nothing else. And what Rajput sir has also touched upon, that the CRGO is a one-off problem, but now we are getting, maybe after 1 year or so the problem will be solved, but the evacuation, that will take another 3-4 years. So I think I should conclude, and thanks for giving me this opportunity. Thank you.
Thank you, Engineer Sharma from SECI. Your information was truly on power sector challenges and road ahead, and information about SECI, what SECI is doing on the development of India in power sector. So now I hope that Subrata sir has noted many questions, so I hand over to him.
No, it is basically not the questions. Overall summary of whatever they were talking. Bhim started from the perspective of power quality itself. Then Rajput highlighted rather on the material science part, going up to gallium nitrate also. Then on the higher side, 1200 kV. Then Samir put a lot of positions and interesting facts actually, because demand pattern is also changing. That's a big issue. It is not only the generation and all these things requirement. I mean, the smart grid point was also, so that means just my smart grid is, even for a layman, any time he or she switches should get electricity, either in a connected mode or in future, even wireless mode also, with proper quality and adequate quantity. Then only it will be successful, like on other technologies, whatever is there. It's not just limited to particular disciplines. Then on definitely the RE changes also have been talked. How much forecasting is also a challenge, load even for the generation also. Then transmission difficulties, timings, requirement, gestation period, definitely it was earlier advantageous with respect to certain generation, but these generations are very quick enough. So we have to think of by 2070, rather when it is a question of net zero, possibly how will we be balancing the system overall with respect to renewable, may not be other fossil fuel polluting systems be there. Then Sanjay Sharma also talked overall idea about the RE generation, decarbonization, extreme weather condition also. Again, they are reflected and intermittent and all these things. As we see even earlier also, my first question is to Professor Bhim Singh itself, because he has done a lot of work in power quality. Sometimes I have faced also with people that we were not in a position to maintain, quantity was shortage. Quality also we were not in a maintained position, voltage was going down, people were knowing two things only: if the voltage is going down, his or her tube light will not burn. Later on they came to know if the frequency is wrong, then they will not be in a position to get within our entire water in urban area pumped to the top to get it later on used for pressure. Even after that, even the people started knowing the harmonics position also. If there is a harmonics and all these things, particularly in the industries, tension on the drives, whatever the thread mill or jute mill, whatever is there, it will be totally jeopardized and there will be a problem with this. So all the three aspects are there. Now, have we, for correction, have we introduced certain devices like we are akin to using stabilizer with these things. That itself also creates problem in the system. We were not correcting or correcting another device. Now, everything, if you try to see it with respect to the basic supply and this value addition forcibly done, how much is the cost and how much we have to bear right up to the position when other types of generations will be coming. Can anybody throw up?
Really very nice question, that how the power quality going to be, like what I talk about, like won't explain too much what we really thought of doing. This, of course, the voltage fluctuations for voltage deviation or voltage distortion, typically from either really serious power quality problem, it may increase. But I foresee in a little different way. And if we are going to introduce a lot of, let's say, solar in the distribution system, probably those solar inverter is going to cure this problem. Practically what we really look into research like. And we started working probably a decade before and working. Initially I worked with a lot of power electronics putting for power quality improvement in distribution system or otherwise into the system for different appliances, as well as for in general to put like maybe a STATCOM, D-STATCOM in distribution system. Of course, we have a STATCOM for tax device and all those. We work on both the sides. But I foresee that what we work in the probably initially for solar, that what the solar inverter is put, it is supposed to improve the power quality of the distribution system. So when we are putting a lot of inverters with the renewable energy, whether it is a wind or solar into the, whether in distribution system or even the generation system, those inverters of course can be used for typically improving the power quality problem. Really, first we look into this problem only, that the inverter is lying vacant without use probably almost 24 hours. I mean, like a 16-hour solar is not there. And whenever the solar is also there in the daytime, it's not full available. So you have an inverter capacity available for improving the power quality. And we not to make a separate investment. We only modify the control. What we work in the last 10 to 15 years, is just improving probably modifying the control of this inverter, solar inverter, with two additional features of improving the power quality, improvement in this electrical distribution system or electrical system itself. So I foresee there is a good solution may be available further and furthermore. Because we are going to integrate more the renewable energy, either maybe solar or the wind. So all the power electronics converter which we are really going to use in this generation, new generation, we call it renewable energy generation, they are really the boon for the improving the power quality. I feel that way. What really we worked out in last 1 decade too. So even having a voltage, because you are going to put the power, solar power into the grid, it means voltage support to increase. We look into the reverse wave problem also. The voltage get elevated, so we have to control the voltage even on the solar inverter also. So I feel that even if research and industry start picking up, even taking into that also, that the solar inverter should even generate the reactive power also, mitigate the harmonics also. If we don't really draw the harmonics from the distribution system, automatically we really will improve the voltage profile as well as both the way. Harmonics as well as the maintaining the voltage profile means making the voltage almost constant, even typically round the clock. So I foresee in this manner probably it may be really not a big challenge, but it will be the boon that we are going to put more renewable, means we will be able to control the grid much better way. And moreover, I think what it was thought about that we have to put energy storage also into the system. That is required for renewable energy. And of course, we might be putting some of the inverters for renewable energy system, but Mr. Rajput talk about like we have typically grid, even a grid forming or grid otherwise as a kind of microgrid. So I foresee that there is a good chances of improving the power quality further into the distribution system, utilizing this asset of power electronics or power converter putting into the typically into electric sectors like. So that's my view on.
Okay, next point is basically we are going to the transition point, right from AC dominated grid to partially DC and all these things. We are losing gradually inertia, and as Samir was telling last year that May 2023 phenomena, or even Narasimhan talked about 7,000 to 8,000 losing in Rajasthan pocket itself. We have seen the recovery voltage was not expected because reactive power through the inverter support didn't come in time. It was having sufficient amount of lag. That's a big issue. Finally, we may be reaching even maybe after 50 years or something complete DC. We have to bear with this type of transition. What is the way out for handling such things? Can we with the BSS storage also, pump storage and all these things, inertia as well, because basically it is an active and reactive power management. Both can be taken care of. And the second issue is, gradually will we be making it completely DC or not by 2070 or something like that. Anybody? I think Samir will be better in the mix.
Yeah, thank you, sir. Very pertinent question. In fact, we have been facing this problem, and part of this problem, this is, first of all, let me say that this problem is not unique to our country. It is happening worldwide. Worldwide system operators are facing this problem. We are part of a group where large power grid operators get together and share the problems, and this is a problem almost all grids in the world are facing. But in our case, part of it is getting more severe because of the large concentrated masses that we are building. Say a 2000 megawatt solar park, it will be spread over few square kilometers, It will be a very, very big area, and the control cables would be traveling quite a big distance. So those delays lead to controller interactions, and they are also part of the problem. By the time one inverter senses a voltage drop and reacts, another inverter senses a voltage rise and reacts in a counter way, sometimes lead to oscillations as well. But the point here being made is that we have been insisting that if you comply to the standards at the point of interconnection that the CA has brought out, that would mean maintaining slightly higher voltage as the terminal voltage at the where the physical inverter is located, or those kind of things. So those measures, if they are taken, then compliance to standards would help operate in a more secure and a reliable way. That would be my response to this. And of course, reactive power compensation, while the studies are carried out, amount of reactive power compensation to be installed is also being made out. So dynamic compensation, synchronous condensers and all would have a very, very important role to play going forward.
we will be stopping the questions over here, but now it is open to floor. Anybody can ask the questions, please. Let us start from right from the beginning on the first row itself. Can you give one mic?
Yeah, good afternoon. I am Professor Rajesh Gupta. I am from MNIT Allahabad. So my question is that we have seen RE integration and many aspects. So one of the aspects, some of the experts have also expressed the use of energy storage, and we have seen some projections like 27 gigawatt of battery energy storage by 2030, and for about 4 hours backup around 108 gigawatt hour. So what is the roadmap for implementing such a large battery energy storage in our country? Because we have seen other countries like Australia and others are very quick on installing the storage. So right from manufacturing to operation, I think Engineer Sanjay Sharma could be a better, because he talked about round-the-clock schemes. So does it also include this part? So,
Hello. Yes, it is a roadmap what government has based on some studies. They have given that 27 gigawatt and 4 hours this thing by 2030. But in my view, it will be achieved much earlier, because right now we are facing a problem that the evacuation system is not ready. CA is in a process of defining the guidelines that because the connectivity we have given to the solar developers, and solar is generated in the daytime only. So maybe after 7:30 or so, they may snatch the evacuation system from those already awarded, and in the place where the grid is not utilized by those solar systems, we are putting up, and we have brought by tender also that during that period, the BESS system will be in place, and that BESS will be charged by the solar behind, or say RE behind, or say wind behind, okay? And during off solar hours, that grid will be utilized, and this way they will meet the peak demand also, as well as they are utilizing the grid evacuation system. So that way we have planned, and because of the constraint in the grid, we are forced to innovate the product like this. And I am sure that right now 31 gigawatt ISTS connected RE projects are in operation. So those will be utilized, and it will be achieved much earlier. There is no need of any roadmap kind of a thing. Thank you.
Batteries are the not single source for storage. There are other storage devices. Lot of emphasis is there on pump storage plants. Those are more stable, have long life, and they can give large quantum. Regulation is also quite fast. Of course, battery is the fastest. But the battery technology has to improve upon. At present, we are relying more on lithium. But what in my talk also told, that research and innovation and the technology. So we have to think of the flow batteries are also there, and they would be more suitable for the utility scale storage. Let EV find the place in mobilities. And another form of the storage, say photothermal storage is also there. So far it has not developed. The obvious reason is that the cost is high, per megawatt cost is high. But it will give 24 hours of supply if properly designed. So that also need to be experimented. 1 or 2 units are there, but due to some reasons, their performance is not up to the mark so far. Maybe some design changes may be required. Other type of the storage, they are in the electromagnetic and the capacitive storage, and you can say the flywheel also. Then compressed air energy storage systems are also there. And say typical type of the sand and the oil, typical oil, they can store the energy for a large time. And research are also going on, and people are claiming that even the concrete blocks, they can store the energy and then they can serve. So it will be basically a combination of all. I simplify it in my own way. Say we are, I think, 130 or 140 crores people in India, each having unique personality and unique contribution. United together, we make one India. Similarly, whatsoever the little sources are there, they have to contribute, and we have to make wiseful use of the energy. The concept of life, which you might have read in newspapers and other things, lifestyle for management. So that concept we need to follow. It's not that per capita consumption, say, which we are having 1400 units per capita consumption per annum. Okay, it's a respectable figure. It may go up. If it goes up because of the industrial and the agricultural sector, then it's more advantageous. But for the personal luxuries, in my view, it should come down. So some balance has to be maintained. And of course, we should not ignore. We should give more emphasis on the research, and in the transition period, whatsoever are there, we are now capable, and our economy is also luckily sound, and India has its own say. So we should acquire the technology and put up, say, joint ventures from here, those who are having a better technology than us. So these are my views. And just one more thing which I touched about the losses, because sir told that he has seen me in the distribution system. So we always say that reduce the distribution losses. All your efforts of capacity addition and expansion of the transmission system could be deferred to a large extent. So that need to be realized, and that need to be brought into the practice. Thank you.
Little bit. Yeah, the thing that we have seen the time, then when solar is coming up, we found it. I mean, I work in the power quality for long, around 20 years. And when solar inverters start coming, I thought it, okay, why not to use the inverters of solar inverter to improve the power quality. Now you will just see the battery is more costlier than solar now. Unable to follow, like. So maybe that tomorrow we will see, like, if we are able to convert a lot of energy from renewable like solar to electricity, tomorrow we will be powering it to electric vehicle. And then this electric vehicle storage like batteries especially will support to your grid as a smart grid. Like that will be the energy of suit, like 50% energy in, you can call it transport sector is 50% energy used. That 50% if comes from electricity, certainly those vehicle storage will certainly help us to make our grid smarter, especially the distributed energy. It's not a concentrated energy that you are making battery energy storage plant at the moment, and it's very difficult. You put a, let's say 10 megawatt and then you have to take back 10 megawatt. It is all distributed in the different places as a charging infrastructure or putting energy back into it. Like, I mean, Tesla also coming up and so much vehicle, four-wheeler will come up. So we'll be having certainly the spare capacity of the battery in all these vehicles. So we hope tomorrow that will be the solution to probably take care of this problem as a energy storage. And moreover, this battery also will become cheaper than there is a heavy requirement of the vehicle, like electric vehicle I'm talking about. That's just to add like that.
Just one sentence. And say another parallel technology, we are much talking about the green hydrogen. Right now, of course, the green hydrogen is costly. Reason is because in a lesser quantity. If you produce it in bulk, the cost will come down and the competition and also the technology. Because whatsoever the electrolyzers are there, they have certain efficiency limitation right now, but through research it will improve. Hydrogen is also carrier of energy. And when lot of RE is there, and when we talk of, Samir Saab told that lot of flexibility and the ramping requirement of the thermal units are there. So that excess energy could be used to to produce more of hydrogen, convert it to green ammonia, and that green ammonia at the time of the peak could be used to run the gas turbines, because unfortunately we don't have the gas. In the mobility sector, it is well established at present. We do not know what the future will say. The long haul and heavy duty trucks, they are beneficial if they run on hydrogen. And there are research and the models also that the existing trucks running on diesel can be converted to the hydrogen run diesels. Fuel cell is another technology on which lot of research is going on and is required. Experimental trains have been run on hydrogen fuel cell. In India also, the fuel cell based train on an experimental basis will be run maybe in next few years. काम चल रहा है उस पर, तो ये चीज़ें डेवलप हो रही हैं. तो अभी 80 किलोमीटर पे है जो डीजल रूट ऑफ द ट्रैक, रेलवे ट्रैक, that will be substituted by the hydrogen one. And of course, first the pilot and then on the mass scale. So these are certain things.
There were questions expected. Anmol.
Good afternoon, everyone. I'm Dr. Anmol from NIT Delhi. I have two questions from the panelists. One is, so are renewable energy fed DC only grids actually feasible and practical in the present scenario for the low to medium power applications? This is the one question. And second one is, if you can elaborate a bit more about the grid forming converters and their actual requirements.
I think first question was related to the DC grid.
Right, sir.
Well, the DC grid, of course, cannot be a big grid. I feel that DC grid will be confined to like maybe the homes which have been probably in the noise for, maybe data centers, because you might be generating like maybe solar DC, and you may be powering the equipment which can be driven by the DC. So that, but it still cannot be a big micro grid of the DC. I hope it will be localized kind of the DC application, which are at the moment also will increase also in future. That is probably the answer of first. And the second is, as far as grid forming converter is concerned, that will support to come more as the microgrid comes more in picture. I mean, because if microgrids are there more, certainly you need the grid forming converter. I mean, you will not like to make probably the grid forming with the help of diesel DG sets or something like that. You may like to keep an energy storage like battery and the converter from it. So those will work, or maybe the solar inverter itself will work as a grid forming converter. So hope that as a microgrid will pick up a lot, because microgrid can take from solar as well as from wind and other sources also which we are talking about, maybe either small hydro, biomass, so many are there that will be a part of along with the energy storage. So grid forming converter will certainly come big and big, as it was mentioned it. More and more, as probably as a distributed generation, it pilots the more, or renewable generation comes more. So that will be I feel that grid forming converter have to come, otherwise you can't run those electronic distributed generation. So that's the probably partial answer to your question.
Thank you, sir.
I will supplement it. It's quite interesting. We are much fancy about the LVDC, and for your information, LVDC forum is in IEEE also, as well as in our Bureau of Indian Standard. We also studied it. Some from IIT Chennai this thing started, but as sir told, it's a clear-cut analysis. Suppose if this building is there and most of the appliances here are DC, so let it be DC. भेड़ चाल नहीं होना है, ठीक है, एक को देखा एक चल दिया. Because what has happened, we have developed initially from the DC, from the days of Edison, then the war of electricity, then AC prevailed, and also the HVDC is in existence. So that has its own application and unique characteristic and unique advantages. LVDC also we can have, but build up a new smart city or a smart housing society and like the thing. Whatsoever the gadgets they are there on DC, use them. But since here is AC, I can't put the another wiring for the DC. and where my appliances or the motors or whatsoever else, they are running on AC, how suddenly they can run on DC? So it's a legacy, or you change it completely as a policy. Let someone compensate. So these are the things, and the wire size will be thicker for the fittings, and the switch is also for the DC. So this is all, and we should read the book, The War of Electricity. That will around 500 pages book, freely available on net. Search it, read it. You will find it interesting.
Sir, good afternoon. I'm Professor Y.P. Verma from Punjab University. My question is from Mr. Saxena. You have given the statistics that we have 45 gigawatt of generation capacity. Peak demand is around 250 gigawatt. So what are the reasons that why we are not able to meet our the daily requirement? Because we face lots of cuts in major cities also. Is it the aging infrastructure, the transmission capacity? What are the practical difficulties that power grid is facing?
Yeah.
On that. And number two is, how do you see that peer-to-peer trading, in Indian context?
Yeah, so thank you. That question is very often asked. In fact, the policymakers sometimes also get into this and ask us this question: 445 gigawatt installed capacity, 250 gigawatt is the demand, and why we can't meet the difference? We have a lot of capacity available. But look at it this way: at any point in time, around 70 to 80 gigawatt capacity is under outage for different reasons. That is one. It may be planned outage, it may be forced outage, or whatever reason, 60 to 80 gigawatt is, and this keeps varying season on season and around the year. Look at the number of machines we have. Just if we talk of probably something like 2,000 generators, if I'm not wrong, some ballpark number. So 2,000 generators, they have to do maintenance at some point in time. There will be forced outages also. So one part is 60 to 80 gigawatt approximately is under some kind of maintenance planned or forced. That's one. Look at RE. RE 132, 137 gigawatt wind and solar. Is it available all the time? That's the nameplate rating. 20-25% CUF is what we get, right? So there you lose a lot of capacity on the nameplate rating. Third, come to hydro. Hydro, if you see, we have around 47, 48 gigawatt installed capacity, and northern India, the hydro is largely snow-fed, run of the river, few reservoirs are there. South, monsoon dependent, reservoir based, and the hydro is highly seasonal, very, very precious, and it is conserved to the extent possible, otherwise run of the river runs. So hydro variation, I would say that during high hydro season, we have had calamities as well. I leave that aside. But if we do not have that, we have achieved a maximum hydro of around 41, 42 gigawatt out of the 47 gigawatt capacity in high hydro season, which is say July, August, maybe some part of September. But in winter nights, hydro goes down to 5 gigawatt. So, and it is conserved to meet the peak, which maximum in winters is achievable of the order of 20 gigawatt, 19 to 20 gigawatt. So you see, you lose out, if you strictly go by the nameplate rating, these are the additional factors that you have to consider while you are meeting that. So I hope that partly explains the first part of the question that you had. The second part regarding peer-to-peer trading. So this is a smart grid endeavor, and going forward, this can happen in communities. We would need an ecosystem to be able to establish that. We would need a distribution system operator. A lot of work has been done worldwide as well as in India also about implementing distribution system operators where local communities can do peer-to-peer trading, maybe, but then those kind of monitoring, control, SCADA systems. So the distribution system operator will come in as a very big important player in that. And going forward, we do have the blockchain technology there, which can be used for this. There are some scattered pilots that are happening, but the thing I believe would take some time to mature. So that's my response to that.
I think we'll end up over here because it is already 2:45. We are running with 1 hour 15 minutes with respect to scheduled time. We'll go for lunch. they will be there sure. You can ask questions and get satisfied. So, thank you. Please join us. Oh, you will be there.
Thank you, panelists and moderators, for this enlightening discussion.
Now, I would like to call Professor Prerna Gaur and Professor Subrata Mukhopadhyay to facilitate our panelists with a token of gratitude. Firstly, we have Professor Bhim Singh. Now, we have now we have Engineer Samir C Saxena. Next, we have Engineer Sanjay Sharma. Now we have Engineer Ashok K Rajput. Now we would like to call Professor Prerna Gaur to facilitate Professor Subrata Mukhopadhyay with a token of appreciation. Now, we request everyone to proceed to the dining area for lunch.
See, we will start the technical session right at 3:30 in the respective halls, right? So please, the contributors, authors,